Hello, everyone, and welcome to the Deep Engineering Podcast, where we bring you real world insights from the engineers, architects, and researchers shaping modern software. I'm Divyan Selvaraj, the editor in chief of Deep Engineering, and your host. We are hosting today's session live, and we'll wrap up after an hour with an AMA round that will last for approximately 30 minutes towards the end. Uh, if you have any questions that come to you while we are having the conversation, feel free to drop them into the Q&A tab. You'll find this in the vertical menu to your right. Please also feel free to upvote or downvote any questions, and this will help us manage the ANA round better. So today, as you already know, I'm speaking with Karun Thankachan, a senior data scientist specializing in recommender systems and information retrieval with experience across e-commerce, fintech, PXT, and edtech. He has published multiple research papers and holds 2 patents in machine learning. He currently works at Walmart e-commerce, focusing on improving item selection and availability. Karun also serves on the editorial boards of IJDKP and JDS and mentors aspiring data scientists on TopMate. He's a Perplexity Business Fellow and a recipient of the Top 50 TopMate Creator Award in North America 2024 and the Top 10 Data Mentor in the USA 2025. He also shares amazing practical insights on data science and machine learning with 85K plus followers on LinkedIn. So do feel free to check him out over there. And in today's conversation, we're going to be digging into how small and large language models can be combined in practice through reasoning aware distillation, trace budgeting and cost control, telemetry driven routing, and what all of this means for teams trying to deploy language models in production environments. So, a very warm welcome to you, Karun. Thank you very much for joining us today.
Thank you for having me here.
Wonderful. So, let's get started. Right. So, Karan, your career spans, both academia and industry, and perhaps things in between. Starting from advanced research, for example, at CMU, to applying AI at Walmart. Can you perhaps share with us how this journey led you to eventually focus on SLMs?
Sure. So I started my career as a software development engineer back in India. And there I had the opportunity to work under a director who was sort of starting the data science and machine learning team there. I had the opportunity to work on a bit of data analytics, big data science, and eventually machine learning. And that sort of sparked my curiosity into machine learning, leading me to do my master's in machine learning from Carnegie Mellon. And that's where I would say I got a bit more interested in the research side of things. Had the opportunity to work under a few professors there. Professor John Stamper, in particular, was able to publish a pretty good paper in AAA and got into the weeds of deep learning. Eventually, led me to land a role in Amazon, and now currently as a senior data scientist at Walmart. It was, however, in Walmart with sort of like the ChatGPT slash LLM wave that I got involved a little bit more in the field of language modeling and NLP. Our current director had a vision for agents that could solve specific business problems, and we started trying to develop or meet that vision. During that time, I realized a lot of building agents is a little bit more software engineering than machine learning. It was a lot more about designing evals that could give you feedback on how your LLMs are performing, building guardrails that could make sure that your LLMs are behaving the way that you want them to behave, and sort of optimizing for cost and latency. A lot more engineering focused than, let's say, machine learning focused. And I missed a little bit of that machine learning flair, and that's when I started investigating on my own a little bit more how I could be involved in the machine learning side of things within the AI wave. And I stumbled upon small language models that you could actually fine tune and optimize to specific tasks that you want. And it felt a bit more in the domain of machine learning. It felt more like you were understanding how a model was working and helping the model learn patterns in your data, which was sort of what got me interested in the field. That's what got me interested in SLMs. And it's sort of my opinion that right now we are sort of in a race to who can define this new customer experience that would be based on LLMs. And that's why we are relying a lot more on foundational models, and we are hitting them via APIs, plugging and playing them into our experience to figure out what kind of new reliable experience we can provide to the consumer. And whoever provides that uh, new better experience to the consumer will take over a huge amount of the market. But afterwards, once this new experience is well defined, then we will go back to that age of cost optimization. And that's where SLMs are going to come back into the picture, because they are able to reason more cost effectively on specific tasks, as opposed to LLMs, which are more general purpose reasoning. So that's sort of why I still keep very invested in this domain of
Mm.
SLMs, and I'm hoping that converts in sort of like the next 5 6 years. Yeah.
Yeah, and I think we're going to be talking about that a little bit more towards the end. And you're very much in the thick of things, aren't you? Um, but before that, let's talk about ReasonLite. And for those who are listening in or watching, if you go into the resources tab again in your vertical panel, you'll find Karun's paper over there on ReasonLite. So do check that out. So Karen, ReasonLite was introduced as a way to perhaps tackle the fragmented tooling, unclear evaluation practices, and high token costs that hinder reasoning in small models. What gaps did you see in existing SLM distillation tool chains that made you create ReasonLite?
Sure. So maybe to take a step back and explain what recent light is. Um, so LLM models are models that have a tremendous reasoning capacity. They have general purpose reasoning capacity, and since they are models with billions of parameters, they're also able to, in very layman terms, able to remember a lot more details to be able to reason a solution for a question that you ask. For instance, if you ask an LLM, how do you bake a cake? An LLM might be able to remember all the steps that are required to bake a cake, like preheat the oven, mix flour and sugar, add eggs, bake for like X amount of minutes. So it's able to remember a great amount of the detail. An SLM, in comparison, it doesn't have as many parameters, so it won't be able to remember as much. It'll be able to maybe remember things like flour, eggs, cake. So and how these language models work, they're essentially what we call auto-regressive models. So what it has generated thus far will sort of influence what it will generate next. So if you can't remember a lot of the uh, prior steps to baking a cake, like preheat the oven, flour, egg, cake mix, stuff like that, you might not continue generating the correct answer. Like an SLM might say flour, eggs, brownie instead of flour, eggs, cake, because it didn't have like the correct prior before it. Um, but even though LLMs have billions of parameters, have a lot of memory, it may be sort of overkill when you want reasoning for a specific task that you have in mind. It's really great for general purpose reasoning, but for specific reasoning for a particular task that you have in mind, an SLM might be able to get you there. And the only thing that you have to do is you have to update its parameters, which is currently now for uh, I would say subpar general purpose reasoning, update it to become good for specific task reasoning. So how do you teach these SLMs how to build out that reasoning? So there are a lot of techniques that are there in the market, like COT distillation. To provide an example, here you ask the LLM, hey, I'm going to ask you a question. Let's say a person went to a store where they're selling apples for $3. He bought 4 apples. He gave the shopkeeper $20. How much does he get back in return? Tell me the answer, but show me the steps also. So the SLM will write out cost for an apple is $3, 4 into 3, 12. He gave 20, so 20 minus 12, 8 back. Your answer is 8. So it will show you each of the steps and then give you the answer, the 12. So, like we mentioned earlier, these are auto-regressive models. So what it generated earlier will help it generate more accurate answers in the future. So if I am able to get the SLM to output responses in this similar manner, or at least think in this similar manner, then it's more likely to get at the final answer. So what we do is we ask the LLM to generate its entire chain of thought, and we feed this chain of thought into SLMs and ask it to generate a similar chain of thought. So we don't do this for general purpose, rather we do it for our specific tasks. So it if you try to do it for general purpose, again the parameters will get updated in every which way, and it won't be able to generate good answers again. But if you do it for a specific task, the parameters will get updated to reflect that specific task, and it will start to be able to solve that specific task. So similar to COT distillation, there are other techniques like contrastive rational explaining, which is essentially you tell it that this is the answer that I want, like 4 into 3 is equal to $12. That's what I want. 4 into 3 is equal to $11. That's not what I want. So you push it towards what you want, you push it away from what you want. So there are a lot of these techniques that are out there for helping train SLMs to perform or provide reasoning on specific tasks. But when I was sort of building out SLMs to reason on specific tasks, I realized a lot of these techniques were written in notebooks, they were written in scripts. And what I wanted was something similar to what ML practitioners are familiar with today, which is a kind of hyperparameter tuning, where you have all these knobs and you can turn them on and off, you can adjust the parameters, and you can figure out what set or what combination of techniques helps the model to learn the pattern the best so that it can generalize in the future. So I wanted all these techniques under one roof, like COT distillation, self consistency, program aided distillation, contrastive rational training, curriculum scheduling, like all these techniques. I wanted it in one package which I could control, sort of similar to hyperparameter tuning. And that's why I sort of developed it ReasonLite. Everything was split out in files, wanted to bring it in one package. And with this now, hopefully practitioners can call the package, they can tune it just like they would with HP tuning. And that sort of, I feel, solves a pain point in the current SLM training.
Right. Thank you so much for that overview on ReasonLite. So we'd like to dig into that a little bit more. So ReasonLite integrates program-aided distillation, doesn't it? How does this approach work in a real-world training pipeline?
Sure. So maybe to explain what program aided distillation is, maybe taking our previous example of a person going to a store buying 4 apples, which are worth $3 each. They pay the shopkeeper $20. How much does he get back in change? So if you give that question to an LLM and you explain it, ask it to give you an answer with sort of chain of thought, then what happens is it does the calculation. It says that, hey, 4 into 3 is $12 and 20 minus 12 is $8. So here the LLM doesn't actually have like a calculator doing the calculation. What it's doing is it's looking at 4 into 3 and it's saying that 12 is probably the most likely answer. But at times, an LLM could generate a COT which says that 4 into 3 is $11, just because it's not actually doing the calculation. It's just predicting what's the most probable answer. Same thing, 20 minus 8, it might not give you $12. It might give you 20 minus 8 is $9, because it's just It's just predicting what's the most likely number. It's not doing the actual calculation. So this is sort of a little bit harmful when you are trying to do chain of thought distillation at scale. So just to refresh everyone's memory, what is chain of thought distillation? You ask the LLM to show the steps that helped it get to the final answer, like 4 into 3 12, 20 minus 12 8. Those steps show it. So that's the chain of thought along with the answer. That's the entire chain of thought. That chain of thought, you feed it to the SLM, and then the SLM tries to generate that same chain of thought using its much smaller parameters. But it's only generating it's only being trained on chain of thought for specific tasks. So it will be able to capture all of those limited amount of chains of thought. Now the problem is, if these chains of thought that we are generating from the LLM itself is incorrect, like 4 into 3 is 11, and or 20 minus 8 is 9. If it's from the LLM itself, if it's incorrect, then the SLM obviously can't be expected to learn the correct answer. And you can't sit and verify all your chains of thought, especially when you're training at scale. So how do you make sure that the intermediate sort of, especially math oriented steps are correct? You ask the LLM to generate it in a way that it's like Python language, like the code would be generated as 4 into 3, and like C is equal to 4 into 3, answer is equal to 20 minus C. So your answer is 20 minus 4 into 3, it's 8. So instead of the LLM actually doing the calculation, it just writes the code with the inputs that you provided. The code is taken and run in something like Python or a calculator. The answers are then attached back to the chain of thought, and then you feed it into the SLM. So this way, with this kind of um, external program that's embedded into your distillation, i.e., program aided distillation, you can make your chain of thought a little bit more accurate, and you can get your SLM to learn only on the correct answers instead of any incorrect answers.
All right. So another feature of ReasonLite is a trace budget controller to constrain the token usage of chain of thought traces. Um, in a production deployment, why is controlling the length of reasoning traces important?
Got it. So in production, when you're actually serving answers to users, you run into like actual engineering concerns. One is obviously latency. When a user types in a question, you want to give them an answer probably in a fairly short amount of time, so that the user doesn't sort of drop off from the site, and you don't maybe want to uh, provide a very verbose answer unless the user is explicitly asking for it. If they're asking for something simple, you want them to give an accurate answer, a comprehensive answer, but it doesn't need to necessarily be verbose. So during that time, if your model is sort of trained to think in this chain of thought manner, where it's trying to explain, break down steps, and then get to the answer, which is generally good practice. But if it's trained on fairly long chain of thought, that might kick up your latency, that might increase your cost, because each token costs a little something to produce from the even from the SLM. So you might want to have some kind of guardrails around it so that the latency doesn't increase to an unbearable amount, and the cost doesn't become very cumbersome, or it doesn't become essentially very expensive. The compute doesn't run up essentially. So it's to prevent that you have these uh, trace budget controllers. And how it sort of works is, you can enforce it on in sort of different manners. You can enforce it by saying that, hey, for any particular inference call, you shouldn't take more than X amount of tokens. If you're starting to hit your X amount of tokens, cut your chain of thought short. With whatever you have, provide an answer. It might not be an accurate answer, but it helps you make sure that your token cost is is won't grow beyond a certain particular point, and your latency also won't exceed a particular value. Now, an obvious sort of like question that people might have is, hey, if I limit my token usage and if my chain of thought isn't allowed to grow, won't I get bad answers? Which is like a very reasonable question. So typically, yes, if your model is trained to produce very verbose chains of thought, you will run into that token limit issue again and again with the token budget controller. You will run into that issue again and again, and your model won't be allowed to express all its thoughts and therefore give a good answer. So typically what we do is we have eval metrics which um, m- track things like, is the model being useful to the user or not, like the thumbs up thumbs down feature in ChatGPT. So if you get a lot of thumbs down feature, and if you're seeing that for all of those requests your token budget controller was cutting off your chain of thought, then you can understand from sort of your evals, from your logs, that hey, your model is actually being too verbose. We need to retrain the model so that the chain of thought is shorter, it's less verbose, and it's able to get to the answer quicker. So that's why these trace budget controlling is important in sort of like production settings, and how it sort of helps you limit like token usage.
Right. And if we talk about self-consistency versus, latency trade-offs, I think some of it you've covered already. So techniques like chain of thought prompting and self-consistent decoding can significantly improve reasoning accuracy. However, they also increase compute cost and latency by running the model multiple times. So, how can you balance these trade offs in production systems?
So maybe again, to take a step back, what do we mean by self consistency? So essentially, again, like we mentioned, LLM models are they're not actually doing the specific calculations or specific reasoning. Essentially, they're not actually understanding, or they're not able to derive meaning. What there is autoregressive model. So based on whatever it's has seen, whatever it's generating right now, it's gonna generate the most likely answer next. So sometimes it may be generating incorrect things, but if you ask the model maybe to generate an answer to a specific question 10 times, then majority of the times it might actually give you a right answer. So what you can do, or what is a sort of like a decent practice, is when with your LLM you generate maybe not just one chain of thought, you ask it to generate 20 chain of thoughts, and whichever chain of you check the final answer for these chain of thoughts, and if the final answer for these chain of thoughts is similar in a majority of cases, that is your final answer. For instance, let's go back to our apples example. So 4 into 3, 12, 20 minus 12, 8. Let's say 12 chain of thoughts generate 8, and the other 5 generate 9, the other remaining 12, 5, 17, other 3 generate something like 10. So the majority voted as 8. So now you know that this is probably the right answer. Let's pick up all these chains of thought and let's use that to train our SLM model. So self consistency is sort of a fancy way of saying majority voting. You're essentially asking the same model to generate the response to a question again and again and again and again till it starts, in the majority of cases, starts giving you a specific answer instead of giving you different answers all the time. So that's essentially self consistency. Now, if you try to use self consistency during inference, you're essentially asking the SLM model to answer the same question multiple times, let's say 10 times, and you're picking the majority answer, and then you're giving that majority answer to the user. The problem is, if you do it at inference time, uh, instead of answering one question once, you're answering it 10 times. So the cost becomes 10x. the latency becomes 10x as well during inference. So typically, you don't want to use self consistency at inference time so that you can control the latency. Sorry, you can control the latency. So you only typically use self consistency during your training loops, so that sorry, you only use your self consistency during your training loops, so that you can figure out what chains of thoughts to actually feed into your SLM model. So simple rule of thumb: self consistency better for training time where latency isn't a concern, and cost also to a certain extent, because you're doing a lot of these things in batch and you can append on other techniques on top. Sorry, you can append on other techniques on top. You can actually manage the cost and manage the latency. So use it at training time. It's not something you need to use at inference time.
Okay, you're right. Okay, have some water. So we are moving towards the end of the segment on ReasonLite. But in a practical setting, how would you recommend uh, evaluating whether a distilled small model is truly reasoning versus just guessing the right answer?
Got it. So essentially, like, when you are trying to train an SLM, and like we discussed thus far, what it generates is based on what it has learned so far, what it is currently generating in its sort of like chains of thought, or in its thinking, essentially. So when you are evaluating an SLM, it might not be enough to evaluate it on whether it's generating the final answer correctly or not. Again, going back to maybe like our apples example. So the 4 into 3, 12, 20 minus 12, 8. 8 is the final answer. Does that mean you evaluate it only on 8? You could, but let's say it did 4 into 3, 11, 20 minus 11, 8. It still got to the final answer, but it's because it's not really doing the correct things. It's just again making guesses what's the most probable answer, and it somehow stumbled on the correct answer. So your model might actually deviating from the behavior that you desire, but your answer is still correct. So we don't want those kind of things to spread into production. So we want to not just evaluate the final answer, we want to also make sure that we evaluate the steps in between. So how do we actually do that? We can check um, um, what we call the stepwise behavior. There are like a few things that you can inject into the model, like I would say symbolic verifiers or recent probes. These are, I think, two things that we have implemented in ReasonLite. So maybe to give an example of how these things function. For example, recent probe, it's trying to figure out if the SLM is able to do a specific substep well. For instance, we have mathematical recent probes that help you test if your SLM is learning math very well. For instance, 17 plus 8 is equal to 25. So when you do that addition, there is this behavior called carry behavior where 7 plus 8 is 15. So you need to put the 5 and you carry over the 1, and then 1 plus 1 is 2, 25. That's how you do the math. So this carry behavior is something you want to see specifically if your SLM is learning. So you can within a reason like that, there are like functions that help you test for specifically carry behavior within your SLM. So that's a way of evaluating if your SLM is behaving well on substeps. Similarly, step verifiers are another way of sort of evaluating if your SLM is behaving the way you want it to. For instance, the Apple example again, 4 into 3 is equal to 12. That is a substep. You want to verify if that substep is sort of accurate or not. So you sort of take the output of the substep. The similar output, the step verifier would just be like whatever it's doing, that code it's taking and running and generating an actual answer, and it's just matching it up. So it's able to see if at the sub step level, if it's giving you an answer. So these kind of things, these kind of recent probes and these kind of step verifiers are some things that you can maybe add on to the final answer evaluation, and it will give you little bit more information about how your model is actually behaving.
All right. Thank you very much for those metrics and recommendations. Um, Now let's shift into talking about SLM fusion and multimodal orchestration. So, modern AI deployments often involve multiple models, from small domain specific SLMs to large general LLMs. But traditional serving frameworks usually assume a single static model, which leads to inefficiencies under dynamic workloads. Um, SLM Fusion, from what I understand, is an open source library proposed to bridge this very gap by unifying model merging, routing, and serving in one system. Can you explain the impetus behind SLM Fusion and also talk to us about how it works in a real scenario?
Got it. So SLM Fusion, just to give a little bit of context, this paper was written somewhat a while ago, before I would say multi agents became a little bit more popular, and that kind of like architecture became a little bit more popular. I would say maybe it's a little bit outdated at this point. But SLM Fusion, the idea essentially is, you typically, with LLMs, with their general purpose reasoning capability, you can, with enough RAG and context engineering, get it to answer questions within multiple domains, even with like a single LLM, as long as you have your your RAG engine built well. You have like a retrieval layer that gets you specific context related to this new domain, and you do context engineering well enough that only the relevant info stays inside the context of the LLM. But if you're working with SLMs, since you are fine tuning your SLMs on a specific task, and that fine tuned SLM is only able to reason very well for that specific task at hand, you can't just use one SLM and be hopeful that it will be able to pick up or be able to reason in a new domain as well, because you're training its parameters are limited. You're only able to reason for one specific task. So in this case, what you typically do is you train multiple SLMs, and then you figure out a way, based on the questions that are coming in, how to route the question to the appropriate SLM. So that's essentially the idea behind SLM Fusion. The key thing is, how do you route it to the correct SLM? How do you evaluate when the routing was inappropriate? And how do you not base the routing on just hard coded rules, but how do you learn the routing from user behaviors? Sort of like, hey, it routed to SLM-A. The user didn't particularly like that response, but based on whatever rules we have, that was the SLM to route it to. So now, how do you reconcile the fact that that was the SLM to route it to versus the user behavior? Was it like one question and then a follow-up question that switched it to another domain? So those kind of things, how do you actually evaluate that? How do you learn it from telemetry and try and update this routing over time? That was the core of SLM Fusion. Now with multi-agent architectures, it's becoming a little bit, I would say, easier. But if you're working in SLM, some kind of routing is good. There have been multiple papers, both within ICLR, ICML, AAI, that have come around this routing concept as well. But a lot more updated at this point.
All right. Okay, then. But in production, when would we prefer merging models over just choosing one? Can you perhaps discuss an example use case where merging two specialized models could yield in better results than using a single model alone?
Sure. So again, it comes to sort of how different the reasoning is. that these two different SLM models would have to learn. For instance, let's say within a retail scenario, you have a reasoning model that, let's say it's an anomaly detection model, that sort of needs to decide, that sort of looking at sales of an item and trying to figure out why the sales dropped anomalously. So if a sales of an item drops anomalously, there could be multiple reasons that drove it to it. So if I were building an SLM model, if I saw sales is dropping, then the next thing I would have the SLM model do is be able to generate multiple hypotheses and then figure out what is the appropriate one to chase down and try to answer. um, Within that same context, if let's say I wanted to fix the anomaly, I would want an SLM model where I would give it some context on how, I want you to go and hit this system, change the value to something like this, and hit this system, change the value to something like this. Here the SLM model doesn't need to be, doesn't need to have that kind of broad thinking in terms of like hypothesis generation. It needs a little bit more specific tool understanding, a little bit more integrated with API calls. So the reasoning, how this, the reasoning between both these models would be very different. One would be a bit more broad, generate hypothesis, figure out which one is the right one, and then tackle, run those hypotheses and figure out what's an appropriate answer. And this one is a little bit more tool oriented, a bit more in depth, a bit more specific. It can't afford like inaccuracies because it's interacting with the tool. So the reasoning would be very different in these cases. Rather than trying to uh, build one SLM that could maybe do both, it might be a better idea to separate it out, and it might be a good idea to bring these two into a routed format where you generate the hypothesis, you tell the user that, hey, this, I evaluated X hypothesis, these two seem to be the most likely reason. Then the user sort of tries to understand, okay, maybe I also think that, okay, out of all the ones that I evaluated, this is probably the reason. Let's try and fix this. Let's adjust these metrics or adjust these settings here, and then you route it to the second SLM. And that SLM sort of makes all the necessary tool calls, all the necessary adjustments, and it has more in-depth specific reasoning built into it. So that might be a good scenario for routing.
All right.
And very
And
similar to again multi-agent architectures. Yeah.
yeah, got it. So even though, as you said, SLM-Fusion is perhaps a bit old now, and multi-agent systems have become more commonplace. But if we still use SLM-Fusion as a sort of case study to understand how a request flows through the system, how it decides to maybe use a fast SLM for a simple query versus escalate to a larger LLM for a more complex query. Can you give us an example of that?
Sure thing. So within the router, we have like how the package was implemented. We have a few ways where how you can decide what SLM to route it to. The simplest way, the easiest way to maybe get started is just rule-based routing. You see certain domain keywords, you can route it to a specific domain SLM. The a little bit more advanced manner is sort of getting an embedding out of the user query and figuring out which sort of base embedding it matches to the most. So each SLMs would have a um, um, domain um, domain encapsulated embedding associated with it. So it's everything related to that domain in an embedding. So if the user query matches this domain specific embedding, route it to this SLM. Now the advantage with this sort of like embedding based matching is that if let's say the user asked a specific question that was maybe multi-domain and you routed it to the wrong SLM, or it might have been the fact that you need to split that question, route the first portion of the question to this SLM, get a response, route the second portion of the question to the next SLM, get a response. So instead of this embedding being static, what SLM Fusion does is it provides you the opportunity to adjust those embeddings based on how well you have done on the questions users have asked in the past. So using your logs, you can pull in your logs, the ones that you didn't do well on, those ones you can narrow down on. You can figure out how to update your embeddings for those specific ones that you didn't do well on. And you can even, for a particular question, if you feel like it's a multi-domain question, um, within the router itself, you have a sort of like a tinier kind of like an SLM itself, which can split multi-domain questions into separate questions. So with these sort of knobs, you're not just um, you're not just hard coding how to route it, but you're able to learn over time how the routing should evolve, and you're also able to address like multiple domain questions by using the routing module to split it into different questions and orchestrate it in a manner that you can still use your SLMs, and you don't need to try and encroach, or not encroach, but try and get SLMs to interact across domains. So that would be like the core way to maybe use this sort of a routing model.
All right. Thank you for that. Now let's talk a little bit about telemetry-driven feedback loops.
Yeah.
What signals, according to you, are most valuable for such a loop in a production setting, and how do you feed this feedback back into the system?
Got it. So really depends upon the most critical one, I would say, is like how the user is responding to the queries. So just like ChatGPT has thumbs up, thumbs down, some kind of like user satisfaction score. That would be the best way to assess any sort of like generative system, because the response is being generated or evaluated by the user, and if it's not a helpful one, there's no point in any of these generative systems. So being able to track user satisfaction scores, attach it to your logs, your chain of thought, your final answer, your user satisfaction scores, that sort of being that logging system is sort of what we call telemetry. And being able to narrow down on the ones, like once your logs are all stored and generated, being able to search through your logs and figure out which ones you didn't do well on, and having enough logging to figure out which SLM it routed to, why did it route to that SLM, why did it try to split the question into separate portions. Having all of those logs in one place is what's going to help you build that feedback loop and improve your routing over time. Apart from user satisfaction, you could also use things like token usage, like is the compute cost actually building up? Is maybe a question that was designed for one domain, is your router actually unnecessarily splitting it into multiple questions, and maybe just sending it to the same SLM again and again? I've seen that happen also. So checking if your token cost is for any of the responses you're giving is sort of spiking. Similarly, if your latency, if it's spiking. So these three, I think, would be the top metrics to attach with your like telemetry, or have tracked along with your telemetry with like timestamps and request IDs, so that you can map it properly, and then you can improve your routing layer over time.
All right. Thank you for that. So now, quantization is a common way to reduce inference costs, but mixing models of different precision, um, or even merging quantized weights, can be tricky. So, uh, what did you build in SLM-Fusion, again, to use it as a case study, to handle quantized models effectively?
Got it. So I guess like the just to explain, I guess, why quantization is tricky. So quantization is nothing but you have like different integer formats. So with quantization, what you're doing is you can represent it as like 32 bytes, or like 16 bytes, 8 bytes, 4 bytes. The lower you go, the smaller your models become, the faster the multiplications become, and therefore the faster your SLMs become. So you can make your models smaller and faster with the more quantized it becomes. But again, as you make it quantized, you lose a little bit of information, so it won't be sort of like as accurate. So how it sort of helps you use different SLMs that might be in different quantized mode, it gets a little bit tricky here. But we have these things called, when these calculations are taking place, we do these calculations in these large scale 3D matrices called tensors. And how the calculation within SLM works is, you sort of align these tensors or align these channels, pad it as necessary to get it to the same same integer formats, and then sort of carry forward the calculation. So a little bit, I guess, more on the math side. But the key thing is aligning the tensors so that you not assuming that all the models are in the same level of quantization, trying to identify what level quantization it is at, then sort of working through packages that we already have. It's not like package, it's not something new that SLM is providing, but most of the popular DL packages already provide this. But aligning per tensor per channel so that the calculations actually flow through. And in terms of like apart from just the quantization, sort of like building adapters into your models, so that that's another way to perhaps mitigate. Adapters are still, I would say, a little bit unproven in terms of like the value it adds for the number of parameters it introduces in some very few scenarios where the domains are similar enough, but you need like a slight change in parameters so that it adapts to not a completely new domain but maybe a complementary domain. In those cases, I think adapters work. But quantized models, if they're in different quantized states, having adapters can help you maybe bridge that gap as well. So a little bit math and technical side, alignment of tensors, a little bit more less mathy but more modular side, adapters to help bridge the gap. So those are the two things that I think SLM-Fusion had that will help you sort of work with different quantized SLMs.
All right. Now, SLM Fusion also introduced a fast API-based Fusion gateway that is even OpenAI compatible for inference requests. So, how do you see a system like this being deployed in a production microservice architecture? Could it sit alongside existing serving frameworks,
Yeah,
perhaps?
yeah, definitely. So the fast API backend is essentially to support that same thing. The idea being that within microservices architectures, again, maybe taking a step back, the core idea is that anything that has to do with one specific function is split out and is modularized and kept separate. So your reasoning engine, if it is like this multi-fusion SLM, sorry, multi SLM model, you can keep it separate from everything else. You can update it as required without impacting any of the other microservices in that environment. And with the fast API backend, the key idea being that you can hit it just like you would any other kind of service that you can abstract away. So what we typically call, I guess, a reasoning as a service, RAS, if you want to call it like a new domain. So whenever you need a little bit of, hey, I think I need a little bit of human reasoning in this particular stage to make a decision on what to do next, then just hit the API endpoint like you would any kind of microservice architecture. It abstracts away all the reasoning. It will do the routing within, it will pick the SLM, it will generate an answer, it will send you back a specific API um, that follows the contract. And that API isn't just something that's generated by the SLM, it's filled in so that the contract is always maintained between whatever service you're calling to the reasoning as service microservice. So yeah, that way you can just abstract the whole thing away and you can put it in any kind of like production environment with the typical sort of like guardrails that you have, like trace budget controllers, latency holders, and everything. It will actually stick to the SLAs that you typically expect in like a microservices, multiple microservice architecture system.
All right. Thank you very much, Karan. And before we move further into a very interesting part of our conversation, I'd just like to tell everyone who is like listening in right now, if you have any questions you've been holding on to, this is a good time to post them in the Q&A tab. You'll find this on the vertical panel to your right, and we'll take those up after the next segment. So Karen, let's talk about the future a little bit and make some predictions. I'm really looking forward to what you have to say. So, given the rapid progress in LLMs, some might wonder if carefully distilled small models will remain relevant. I think you hinted at this in the first answer that you gave. Your work, of course, suggests that SLMs remain compelling for deployment to fulfill certain constraints. How do you see the balance between SLMs and LLMs evolving in the next 2 to 3 years for industry use cases?
Yeah, I think it's definitely going to be an interesting balance. My right now, like I mentioned, the idea is to define this new customer experience that you can build with LLMs, and the first company to establish this new customer experience that has a lot of value will acquire a huge portion of the market. They'll capture the dominant market share. Like, even though a lot of people agree that Claude Opus 4.6 is sort of better than ChatGPT 5.2, ChatGPT still holds the lion's share of the market because it was first to market. So um, there's this race right now where people aren't too worried about the cost, so they are willing to take chances on LLMs more, to make calls via APIs or host it in house, whatever it's required, to build out this new experience faster than all their competitors and capture that market share. But eventually, once these new experiences have been defined, once these new experiences within finance, retail, marketing, whatever you want to consider, once it's been defined, then people are going to switch back to the fact that whoever can offer the lowest cost is going to be who's going to capture the customers, or more of the customer base now. So during that point, I think there is going to be a shift from LLMs back to SLMs, because of two reasons. One, SLMs are also getting better in addition to LLMs. A lot of people are now starting to realize OLAMA models that you can run are not that bad, especially at pretty simple non-reasoning tasks. So SLMs are getting better. They're more cost effective, and the hardware that can support like a single sort of like a single person hardware that can support SLMs are also improving, which is why I think down the line, SLMs might be a better option than LLMs, especially to control your costs. The delicate balance here is that LLMs are also getting cheaper. So if LLMs get cheap to the point that the benefit of using an SLM is minimal, then I feel that SLMs might lose value completely, and we might just all be using LLMs on an API call. So I guess it's to be seen over the next 5 years how these things play out. Right now, it looks like LLMs are getting just more and more expensive, more and more compute intensive, more and more
Yeah.
energy hungry. Let's see if there are any major breakthroughs in architecture that make these models a little bit less. If not, I do feel confident that SLMs might be what everybody is using 5 years, 6 years down the line.
All right. And, what about mixture of agents flows? And as you already said, we're already seeing more interest in multi-agent systems where multiple AI agents or models collaborate on tasks. Um, Looking forward, what do you think the future of AI in enterprises leans towards most?
Correct. So right now, a single agent can surprisingly get a lot done. The key thing is how you sort of engineer that context and within the context, you're sort of providing goals to the LLM, and how conflicting the goals that you provide to the LLM are. If you can write your goals in a way that it is cohesive, you typically only need a single agent. And I think there have been like papers that have shown that multi-agent architectures actually don't improve performance in a huge amount of the tasks that you would feel like a multi-agent would be warranted or could help. So there are however, there are definitely like cases where multi-agent architectures could be helpful, and those cases are the ones where the goals for the agent, if you can't write it in a cohesive manner but it rather becomes competitive, in those cases a multi-agent architecture might be warranted, especially agents where one agent is providing an answer and you're not sure about the answer. So you want another agent to evaluate, and if it's a bad answer, ask the agent to redo it. So those kind of patterns, there are quite a few agentic patterns that are popping up, but this one is, I think, a pretty good one, which warrants maybe a multi-agent architecture, because there is a little bit conflict between a person who's evaluating, a person who's generating. So those kind of places, I do feel like these multiple agent architectures would help. And in terms of like mixture of experts models or mixture of experts, though that would I guess be related to more the internal working of maybe some of these LLMs. None of it's, I mean, lot of it's proprietary, so we don't know exactly how it works. But there was a paper, I think, from Google which talked about mixture of experts and how these are billion parameter models. So running through all the billion parameters is very it peaks your latency a huge amount. So instead of that, very similar to, I guess, these kind of routing models that we used in SLM-Fusion, and it was actually inspired by mixture of experts. The idea is based on the input that you're receiving, you don't activate your entire architecture, rather you activate certain layers, certain pathways in your architecture, and those seem to be very reminiscent of maybe how the human brain works, where for each particular scenario you're faced with, you might activate certain parts of your brain more than the others. So yeah, mixture of experts also seems to be a good way to improve both LLMs and maybe down the line SLMs as well. So both are good. One specifically for building mixture of experts for building your general purpose reasoning capacity, and multi-agent architectures for building solutions that are maybe more robust and can be more combative with one another within themselves.
All right. And last question, finally, Karun, are there any emerging trends, perhaps in governance or tool integration, that you believe will significantly impact how we deploy language models in production?
I think right now diffusion models are becoming a little bit more commonplace, and that might be a trend worth checking out. Apart from that, I guess like the main things to focus on is within LLMs. There was, I guess, maybe 6 months ago there was a split between, hey, is investing in uh, parameter efficient fine tuning LoRa, p LoRa, sorry, q LoRa, is that a good approach, along with like alignment, DPO, PPO, those techniques, would that be a good investment of time versus just focusing on RAG and prompt engineering? It looks like the industry is shifting a lot towards RAG and context engineering. One, because maybe it's cheaper, and for the other things, you need a specific hardware. You need to hire people who know how to do it. But it also seems like you can actually get very fairly accurate answers and fairly good reasoning from your LLM models if you actually set up a good RAG pipeline, and if you bolster it with a good um, retrieval, a way to improve or rank the retrieved documents, and again select the best ones on top of it. So don't just have a simple RAG pipeline, fit a model on top, maybe improve the accuracy of your retrieved documents with a ranking model, and also focus a lot more on context engineering. So don't bloat your context a lot more, a lot with a lot of information. look into context compression, look into eliminating things from your context if it isn't relevant. Just having irrelevant things increases hallucinations x fold. So a lot of investment in just good engineering, I would say, combined with good retrieval, seems to be giving a lot more accurate answers, a lot less hallucinations, a lot better reasoning as well. So that seems to be where the industry is focused on right now. Would be interesting to see if it would switch back to um, fine tuning, or if it switches back into how this diffusion trend plays out, and how the cost versus cost of an LLM trend plays out. I think those are like some trends to keep an eye on to see where we need to switch to next.
All right. Some really great advice there, Karan, and thank you so much for all those valuable insights. Um, and now we're ready to move into the AMA. So if any of you haven't left your questions in yet, please do so in the Q&A tab or even in the chat if you find that easier. Um, Yes, so that's the first question. You'll receive an invite to join us on stage, and if you wish to, you can do so and ask any follow-ups. So the first one is from Pavan. And are there any evaluation methods for math-related or structured data SLM, LLM responses, he asks.
So for math related, like the ones that we mentioned within SLMs, recent probes and step verifiers, those would be the two things that we build into SLMs to see if a model is calculating the way that we want it to calculate. You can check out the paper and it will give you a little bit more details about how to implement recent probes and step verifiers. In terms of like structured data, um, again, instead of like step verifiers, apart from your output verifiers, which tries to see if it's following maybe like a JSON structure, something of that sort, within your steps itself, if it's able to understand that hey, JSON starts with like two braces and then it has like a certain types of data that you can put into it, like arrays, strings, numbers, stuff like that. Testing those things out again, either via recent probe step verifiers, that would be a good way to check if structured data is also being generated from your SLM/LLM. But yeah, these are the two most common things that we typically use.
Right. I think that we can move on to the next question. Yeah, oops.
What about self consistency in production apps? Both APIs and SLMs serve. Um, like we mentioned, self consistency, typically we don't put it in during inference time. You typically put it in only during training time, and that's to help train the SLMs better. It really depends on like, should you use self consistency? That question really depends upon the kind of cost you can incur and the kind of latency you can expose to your end user. If you feel like the chain of thought that you're going to generate is going to be short, and maybe you can afford high cost or afford maybe high latency because you want to have to provide like an accurate answer to the user, maybe like in a medical domain, in a finance domain, then maybe during inference time you could try generating maybe 10 chain of thoughts and trying to narrow down on the majority answer. Right now, I would say it's not typically seen, but maybe as sort of like systems evolve, as it gets integrated into more critical systems, especially like I mentioned, medicine, medicine and finance, those two systems, maybe we'll see self consistency in prod a little bit more.
All right. Thank you. Next question, please. I think this one's from Ria. Just, I think yeah, there it is.
What do you think? Yeah, go ahead. Sorry, my bad.
Yeah, what do you think is better long term, using SLMs as an intelligence layer or API based proprietary model?
Yeah, I think this was like our one of our open-ended like questions looking into the future. Right now, I would say it depends a little bit on what your long term goal is, I guess. um, Using APIs as a proprietary model is a little bit more what I would call AI engineering or software engineering. Learning how to use SLMs is a little bit more, I would say, more core machine learning, or what we call maybe like data science, I guess, data science skill set. So if you are invested in becoming, uh, you want to be a person who really loves ML and want to stay in the field of ML, investing your time in SLMs won't be a bad choice, in my opinion. Now, if you're shifting perspective, if it's a matter of like, hey, I want to have a long career, should I invest my time in SLMs or should I invest my time in API based proprietary models? I would say right now, almost all companies are investing all their effort in API based proprietary models. So learning that would be a better choice for your career at the moment, I would say. Um, just learning how to set those up, RAG, evals, and context engineering, these three concepts, if you can get down, I think you can build a good career right now. Yeah.
All right. Thank you for that. And I think, Ria, you also wanted to know whether the recordings will be available. So, yes, if you've registered on AirMeet, you will have access to the session recording. We'll also be uploading the video on our YouTube channel, so you can access it there as well in a couple of weeks. All right. Next question, please. Thank you, Sakit. So, any robust libraries for agent observability or governance?
Sure. I guess Langfuse is probably like the most common or go to, or at least like the one that everybody seems to be using. It's the one that I'm using. In Apart from that, I guess, uh, thinking, I have seen like a few, or I've experimented with a few. Evidently, AI comes to mind when it comes to agent evaluation. But yeah, I guess like Langfuse is pretty good enough in terms of like trying to figure out how an agent is working and how to like establish any kind of governance you want. Probably the most popular one, probably the one that will meet all your needs, I think.
Right. Thank you. Next question, please. I think the next question is, what about self-consistency in production apps, both APIs and SLM?
Oh, I think we answered this one. Yeah.
Oh, did we? Oh, okay,
Yeah.
sorry.
No.
Which one? Okay, then I think we're all done. I think the only thing left in chat is something about world models. I'm not entirely sure if that's a question, but if you know
Oh,
what
yeah.
they are,
Yeah.
yeah.
Yeah. This is a debate, I guess, in the field that LLMs are just pattern matching engines. They don't really have a good amount of understanding. And one of the biggest proponents of world models, I guess, two of the biggest proponents, Dr. Yan Lichun and Dr. Fife Lei, they essentially believe that um, you need to build systems that are capable of um, understanding, and not exactly understanding, that have an understanding of the mechanics behind how the world works. So it can't be just text, it has to be text, audio, visual, all of it combined together to build a model that can understand how the world functions, so that if you teach it something about a specific domain without you having to uh, train it or adapt it too much or provide it a huge amount of new information, if you take it to a related domain, it should be able to reason and provide suggestions on its own. So that's something like LLM models can't do. You need to like set up a new RAG, provide it more information, adjust the prompts. Like it'll hallucinate like crazy if you just shift domain slightly. Like not the LLMs that ChatGPT or anything trains, because it's trained on almost pretty much the entire world. But typically, how LLM models are trained, if you trained on one specific domain, if you move to a slightly later domain, it won't be able to answer. So Professor Jan LeCun, Professor Fifele, they're like top-notch researchers in the field. who are trying to build models that can actually do this. In case you are interested in learning more about it, I actually think I have an article around the same that I can share in the chat. Give me like 3 or 4 minutes and I'll send it across.
Yeah, sure. Um, all right. I don't see any more uh, questions coming. Oh, there's one, a new one. Hang on.
Oh, that's just me. I just
Oh,
pasted the article. Sorry.
no, I think this is from, I think Sakib has been sent a question. So what does context rot look like in a production system, and how do you catch it before it compounds?
So, context rod is essentially when um, um, whatever information that you're providing to the LLM is no longer useful to whatever the LLM is trying to solve. So, typically, how do you identify it? Your usefulness score, whatever user satisfaction metrics that you have, will start to drop. The questions that the users are asking will drift from maybe the questions that the users have asked before. So just keeping a track on your user satisfaction scores and keeping a track on how your user questions are coming in and how they are drifting over time, those will help you understand if the model is being asked to do something that it maybe wasn't built to do initially. And this can happen, like you build a solution for maybe anomaly detection at first, new as the business evolves, maybe new reasons might lead to anomalies, but the LLM isn't updated on these sort of new business paths or new business changes that have come into place. It doesn't have any context on it, doesn't have any rag that's picking up this information. So when a user asks about it, it's not able to answer. And just looking at, like I said, user satisfaction and how your questions, you can just pick up like the embeddings of the questions and see how it's drifting over time. That would be a good way to see if your model might be susceptible to context rot.
All right. Thank you very much. And that brings us, I think, to the end of our AMA. Thank you very much again, Karun, for your time and for your very deep and valuable insights. And thank you to those who joined us live today. And if you'd like to attend more events like this, do follow Deep Engineering on LinkedIn. Also, keep your eyes peeled for a newsletter issue from Deep Engineering featuring Karun Thankachan's interview, within which we'll distill this conversation into a feature and also link you to the video recording on YouTube. We'll see you next week with more conversations with experts. Thank you
Sounds
again.
good. Thank you. Thank you all.
Yeah.
Bye.
Bye, everyone.